All right. So we're gonna use second trace a lot, and you have value 0, min, max, and intersect. Those are the 5 that we use the most. And I'm just going to tell you what we use them for. Second trace value, okay, finds the y value given the x value. Finds the y value if you give it the x value. That's bullet number 1. A second bullet that goes with value is we use it to find the y-intercept. And the y-intercept is always going to be 0, and you're going to have to figure out the number, right? And so just to make sure, the y-intercept is always right there. It's where it crosses the y-axis, okay? 0 I'm not going to use, okay, but other teachers may, but I don't. Min or max, okay, used to find the lowest part of curve. It'll actually be an x and a y coordinate, okay? And the max is used to find the highest point of curve. So you have to choose wisely on that one. Intersect finds point of intersection between curves. We also use it for to find the x-intercepts. X-intercept or x-intercepts. Okay. So we use that. So this is a bit of a review from last year. So if you were not in grade 11 applied, this is going to be new to you, how we do it. If you want to do it by hand, if you prefer doing things by hand, you can do it, but be aware that a lot of these are tricky, meaning they're not easy to factor. They're like things are much more complex. So you might want to learn how to use these functions. So you're going to see curves like this. So if you have a parabola like this is called, anybody remember what this is called? Vertex. And in this case, it's actually a maximum, right? This is called x-intercepts. Can you see that? Or yeah, this is an x-intercept. This is an x-intercept. And this over here is, we call that the y-intercept. Okay. I'm going to give you another version of this because we're going to see different functions. You could have one that goes like this. Just sketch it the best of your abilities. It doesn't have to look exactly like mine here. Here, we have what we call the max, right? That's how you would find it. We're looking at functions here. That's the max. And what would this be then? This would be our min. Okay. Vertex is very particular just to parabolas, to quadratic functions. But in general, we'll just call them max or min, okay? That refers to the highest and the lowest point on that particular section. So we kind of hone in on that, okay? So just a review, and because we're going to use the calculator a lot, I just thought I'd take a moment to review those 5 functions, except for we don't use 0, so it's technically just 4. Okay. Let's go to our first page. Are we good, or? Okay. So we're going to go to page 3 here. A polynomial function contains only the operations of multiplication and or addition / subtraction, has real number coefficient, so where x and y are part of the real numbers, whole number exponents, has a degree. And how do we determine the degree? The degree is determined by the greatest exponent of the function. There's something called the leading coefficient. It's in front of the variable, right? The leading coefficient is in front of the variable with the greatest exponent. Okay. The leading coefficient, the LC tells us the end behavior of the resulting graph. Okay. The constant, every polynomial function will have a constant. Okay. Every polynomial has a constant. It's the number without a variable attached to it. And here's a different color probably for this one. The constant, if it's a polynomial, right, will be the y value of the y-intercept of the function. More later. Intercepts. The y-intercept is where the curve crosses the y-axis, therefore x is equal to 0. So we state it as 0. Right? Maybe it's important just to know that the y-intercept will always be 0 something. And the x-intercept is where y is equal to 0. So we'll always have a number followed by a 0. So those are actual points. Okay? And the degree of a function, we will explore and conclude that the degree of the function determines the shape of the resulting graph. I'm going to use a different color for this one. The degree of the function determines the shape of the resulting graph. In grade 11 applied, we looked at quadratic functions. In grade 12 applied, we look at cubic as well. For each of the following, determine the leading coefficient, the constant, the degree of the function, and the y-intercept. So here's how it goes. The leading coefficient is the number, right? The value in front of the variable with the highest exponent. In this case, the variable with the highest exponent is just 1, right? It's just x, so the leading coefficient is 2. The constant is the number without a variable attached to it. So it's -5, -5. The degree of this is just 1. Okay. I will say this. X is equal to 1. And I'm just going to go arrow. I'm not going to go equal sign. But therefore, the degree is 1. And the y-intercept is 0, whatever the constant is at the end, -5. So the y-intercept is very easy to determine without a calculator, even though you may use it if you want. Okay. What about this one? What's the leading coefficient here? It's -1/5. Okay, -1/5. The constant is 25 positive. The degree, right, it's x squared, therefore the degree of this whole entire function is 2, and the y-intercept is governed by that constant there, 0, 25. Okay. Try a few more. Leading coefficient here is negative 5.78. The constant is negative 75. The degree is 2. The y-intercept is 0, negative 75. And remember, they may not always be in order. Convention dictates we should go highest power and then slowly go down, but I could see them flipping it on you. So in this case, the leading coefficient is in front of the x cubed term, so 4.12. The constant is negative 50, because that's the only number that doesn't have a variable attached to it. The degree of this is 3. The y-intercept is negative 50. Okay. So I want you to write the y-intercept as a coordinate. I know that I don't know if in pre-cal you write it as like y is equal to negative 50, but that's actually an equation of a line. We're finding a specific point where x is always equal to 0, okay? All right, so we've got this out of the way. We can always extract this from any polynomial that we're thrown at. So here are the only polynomials that we study on this page right here, summarized. So we have a constant, a linear, quadratic, and cubic. Okay. It doesn't have a space for it here. So what I'm going to do is I'm going to ask you to, at the very top of this thing, at the very top, I'll give you what it looks like in general. A constant function always looks like this. Y is equal to a number. There's just a number there. That would be the equation of a horizontal line. Linear looks like this. AX plus B. Quadratic looks like this. AX squared plus BX plus C. Cubic, y is equal to AX cubed plus BX squared plus CX plus D. Oh my goodness, right? That's as far as we go. And I just have to tell you that for a cubic to be cubic, everything else could be 0. Everything else could be 0 except for A, and you have a cubic function. Okay, so these components here do not have to be present, but they may be present. Same here. For something to be a quadratic, you just got to make sure that A is not 0, and you've got yourself a quadratic. Same with linear and constant, okay? So here we go. Here's one thing I want you to observe. Number of x-intercepts. This one has none. This one has none, except for y is equal to 0, then you have infinite. When it's like right on the x-axis. Note, y is equal to 0, infinite. Will that be popular? Not, I don't think so. Number of y-intercepts that this could have is 1. Every function, every polynomial will cross the y-axis at one point. Okay? And that's how you write that. Okay? End behavior. Okay? I need you to understand this. End behavior, look at the quadrants. I'm going to highlight this real quick here. There's quadrant 1, 2, 3, 4. So when it comes to end behavior, we're going to look at those quadrants. You know what? It's not too bad. It's just you need to know where are the ends going to end up, basically. So end behavior for a constant. It could be quadrant 2 to quadrant 1, quadrant 2 to quadrant 1. right? If it stays somewhere up here, it's always going to go from 2 to 1, and that's that. Or if that line is just below the x-axis, it could be quadrant 3 to quadrant 4. Do I need to use Roman numerals? No, you don't. Okay, just need to be familiar with them. The domain is all of the real numbers. And I'm going to use both notations here. We're going to review domain and range later on. But right now it's set notation, interval notation, right? It's all of the x values. The range is simply whatever that number is. Whatever that number is of your function, that is the range. It doesn't go anywhere. It just stays right there. Okay. And then number of turning points, none. 0. Okay. This one never turns. It just stays on its course. Okay. So that's the constant. Very rare, but you need to know about it. Linear, number of x-intercepts. It could have 1. Okay. It will cross it at one point. Number of y-intercepts, 1. And here's where you need to watch out. What's the end behavior of a linear? Well, it could be this way. So it would be quadrant 2 to quadrant 4. Or it could be quadrant 3 to quadrant 1. How do we know that? If the leading coefficient is negative, write this down. If the leading coefficient is negative, then we are going from quadrant 2 to quadrant 4. If the leading coefficient is positive, we're going to go from quadrant 3 to quadrant 1. So positive, negative. So the leading coefficient tells us that. The domain is still the same. Nothing changes there. This will change once we do word problems, okay? The range is also all real numbers. So you could go all reals like this. This is the set notation. This is interval notation. Because it will just expand indefinitely all over the place. So all real numbers go. Number of turning points, 0. Okay, none. It doesn't turn at all. You see that? There we go. And quadratic, number of x-intercepts, the answer is it could have 0, 1, or 2 x-intercepts. This goes back to grade 11, right? So 1 right there, none, and this one has 2, right? So that's one thing I need you to know. Number of y-intercepts is always 1. End behavior. This has to do with a leading coefficient as well. If the leading coefficient is negative, okay, it goes like this. Look up here on the screen. It can go like this. It doesn't matter. What ends up happening is that you go from Q3 to Q4, right? It's always going to end up in those quadrants. So Q3 to Q4. Or if the leading coefficient is positive, then it's going up. It's going to go from Q2 to Q1. There we go. The domain, it's still the same. All real numbers, because this opens up to the sides indefinitely. Okay. Range, it depends. Okay. If the leading coefficient is negative, okay, then the range, let me just make sure I have that the same notes as you. Then the range, if it's negative, it's going to be y is less than or equal to the y value of the vertex. More later on this one. If the leading coefficient is positive, then it's going to be y is greater than the y of the vertex. How many turning points? Always one. Okay. And what do I mean by turning point? Right? If you travel along any of the parabolas, at one point you turn and you go the other way. Right? So same with this one, you turn and then you go the other way. It happens at the vertex. Cubic. Cubic can have 1, 2, or 3 x-intercepts. Go figure. Always one y-intercept. If the leading coefficient is negative, something happens. If the leading coefficient is positive, something will happen. Okay? And I'll tell you what, we're going to copy paste the linear and behavior. If the leading coefficient is negative, if A is negative, it goes from Q2 to Q4. Okay? Q2 to Q4. If the leading coefficient is positive, we always go from Q3 to Q1. And you should see that odd degrees have the same end behavior. Okay? Functions with odd degrees as well as evens, they're going to have the same end behavior. The domain and range stays the same. It's a little irrelevant in this case, to be honest. For the range here, it is also y is all real numbers, negative infinity to positive infinity as well. Number of turning points, 0 or 2. I will say or, just not comma, just go or 2. So it's either it has 0 turning points or it has exactly 2 turning points. That's the thing with cubic functions. Okay, I just want to say this. I'm going to ask you to, at the bottom of this table, just write down degree. Okay, so this is a degree of 0, a degree of 1. Oh, it is at the top. Anyways, never mind. It's okay. I forgot that it is already at the top here. But 0, 1, 2, 3, and there you have it. Okay? Question? Oh, for the range here, this is supposed to be y. Thank you. This is supposed to be y. Please change that. Yeah, the range always has to do with the y values that are permissible. The domain is always the x values. Okay. Okay, let's keep going. I'm going to right. Where are we at here? Okay. Come with me here to page 5. I want you to, I know it's been a lot, I overwhelmed you a little bit. Okay. I want you to see if you can match these functions here with the graph that it should go with. Okay. And I know you may get some of them wrong, maybe you might not know exactly, but try to eliminate, try to find the ones you know for sure. Right? Try the ones you know for sure and then fill in the rest with whatever other function may apply. So please take a couple minutes and try to match. So if the first one is G, then put G underneath it, right? Put the letter of the function underneath it until you find them, until you pair them all up. Try that. see how it went. Maybe I'll give it a bit of a different approach. So when I look at this, I know that the degree is 1. The leading coefficient of this particular function, I expect it to be negative, okay? Because leading coefficient of a linear, it goes down from left to right, so I know that. I know that the y-intercept is going to be, apparently, it seems to be 0, -3. Okay, so a couple things just by looking at the graph that makes sense. So I'm going to go look for a degree of 1. That's one right here, and there's one right here. And it's a little tricky because both of them have a y-intercept of -3. So that makes it a little trickier. Okay. Maybe, I don't know if you tried the slope method. Do you remember your slope? This one has a, slope is the rise, right, versus run. So this one has a 2, 1. If you think about it, it's 2, 1, 2, 1. So this one has a slope of -2/1, actually, this one in particular. So Q is the first one for 2/1. I believe this is the one, right? Yeah, this one is Q. Q goes with this one, so that one is out. Okay, that one is out. So I need to, then technically this is my other linear right here. I'm gonna just assign that and say, hey, I'm also done there. And if you think about it, this one is steeper than this one, right? This one, like if the slope is half, it's not as steep as if it's negative. So this one is done as well. Now we have this one. This is a quadratic for sure. Degree is 2. The leading coefficient is going to be positive on this one. It's going to be pointing up, right? And my y-intercept is 0, 1, okay? 0, 1. So which one is it going to be? I'm going to go look at the quadratics I have right here, and in this case, you narrow it down to k, right? This is k of x right there, so that one is out. Okay. The other one right here is also a quadratic, but in this case, you can tell it has to be, there's only one quadratic left, but let's say you didn't know that. You'd still look at, okay, it looks like a parabola, leading coefficient is positive. My y-intercept is -2 right here, so that must be the one that is still remaining, okay? So jx is also out. Now we have the cubic. And watch this. These ones are, this is degree of 3. What's my leading coefficient going to be? I want you to think of a linear function, okay? When it's positive, it goes, a linear function goes like this, right? So I know that this has a leading coefficient that's positive. This one has also a degree of 3, but in this case, the leading coefficient is negative, okay? Because you're going down like this, okay? In this case, it's going from quadrant, right? This is quadrant 1, 2, 3. It's going from 3 to 1, like this. So I expect this to have a leading coefficient that is positive, and the y-intercept in this case is -2. Okay. So I'm gonna grab the one that has a positive leading coefficient. This one right here. This is p of x. That goes with that one. You can't see that, but this is p of x. That is gone, and then the one that's remaining is g of x. Okay. Because it has a negative leading coefficient, and then you know which way it's going to go. Okay, let's keep going. This summarizes everything that we've just talked about. Okay, watch this. If the leading coefficient is negative, then you expect the graph to drop from left to right, and so it is with the cubic. Okay, it's gonna always go from Q2 to Q4. If the leading coefficient is positive, we expect it to go from Q3 to Q1. Even if it does this wonky wavy thing, it still behaves the same way. The ends end up in the same quadrant, okay? And for a quadratic kind of is on its own little island, okay? If the leading coefficient is negative, we expect something like this. It's always going to go from 3 to 4. If the leading coefficient is positive, we always end up quadrant 2 to quadrant 1, right? So that is, in summary, what we've been looking at. That the linear, right? So linear and cubic have similar end behavior. So the leading coefficient tells us that. The leading coefficient is the one that's telling us that. All right, this stuff I'm going to keep bringing up again and again, and we're going to get better at it. So let's now graph on paper. We're first graphing it on our calculator, then we want to put it on paper. Okay. So grab your calculator. When I ask you to graph, these are the things I always want you to find: all the intercepts, local maximums or minimums. And then for the graph itself, you've got to make sure you have scales, labels, intercepts, min and max ready to go. Okay? So for some of you, this is new, and it's just going to be a learning curve. There's a reason why there's grade 11 applied before grade 12 applied, all right? So let's turn this on. We're going to go to y equals. Clear whatever is in your y's here. Clear it all. Just press the clear button. Okay. We're going to enter this into our calculator. Before we do so, what can we tell just by looking at it? We know that the degree is 1, so this is linear. Okay. We know that the y-intercept is 0, 15. And what about the end behavior? The leading coefficient is negative, correct? So we expect this line to do this. This is going to go from quadrant 2 to quadrant 4, right? That's what we expect to happen just by looking at it. So let's enter it. I don't know if you remember from last year, if you have a fraction in front, brackets, okay? So I'm going to use brackets. You always have to press the negative. Look up here, okay? Negative for a negative leading coefficient. Do not use the minus. That's going to give you an error. So negative 2 divided by 3, close the brackets. And everybody that hasn't taken grade 11 applied, this is your x variable button right here. Don't press times, that's not x, right? So x and then plus 15. So the only time you use the negative is for the very first, the leading coefficient. Other than that, you can use minus or plus thereafter. Let's graph it. This is what I'm seeing. So I will suggest to you to use Zoom Standard. Let's press Zoom, because I don't know, other grade 12 students will have used it last year. So Zoom, and then we select Zoom Standard. That's a standard 10 by 10 window, 10 in every direction. It doesn't do very good, does it? You see it here though? Right? You see just a little glimpse of it. This is where I want you to use the window function. Okay? Let's press our window. Do I need to review this? Here. I want you to write this down real quick somewhere on the side. If this is your window, the top of your screen is governed by whatever is in Y max. The bottom of your screen, how much you see towards the bottom, is governed by Y min. This is going to be governed by X min, and this is going to be governed by X max. So those are the boundaries for your screen. So guess what? Right now, if I look at my graph, I want to make sure I see more towards the top. I'm not going to change too many things. So what will I change? I will change Y max. I'm going to go to my window, and I'm going to maybe triple whatever I have in there right now. I went 30 into my Y max. I don't want you to use any other entries. I just want you to use X min, X max, Y min, Y max. Hit graph. That's pretty good. I see the y-intercept, but I want to see the x-intercept as well. So what am I going to change on my window? The x max, correct? So I'm going to go to my window, change x max to 30, and there it is. That's what worked for me. Okay? Now, how do you find the y-intercept is already taken care of? How do you find the x-intercept? Right here, x-intercept, this is what I do. I let y2 equal 0, and I go second trace intersect. Intersection, that is. So if you need a review, you go to y equals, you let y2 equal to 0, hit enter, then graph. And it's going to graph a horizontal line along the x-axis. To find this point, we go second trace intersect, so we select 5. And all you have to do in this case is hit enter 3 times. Enter, 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 and it's going to go to that point right there, which is 22.50 for me. There's my x-intercept. And for a linear, that's all you need. Yes? Yeah, so these are the keystrokes. Yeah, something along these lines to show me what you've pressed to find it. And for a linear, guys, that's all you need, x and y-intercept. So let's go graph it. I want you to put arrowheads on your axes. Label it. In this case, it's just XY. Let's see what scale we should be using. 22.5, if I make this 5, 10, 15, 20, it's going to be tight. So if you want to do it that way, I'm going to extend it a little bit. Just extend your axes a little bit. Call this X, and then we'll make this the extension. So I will go 5, 10, 15, 20, 25. It's very important that you keep it consistent. And so I'm going to go into the negatives a little bit. There, you're telling me that you're using a scale of 1, basically. Every box is worth 1. And here I'm going to use the exact same scale because my y-intercept is 15. Okay, if you look up here, this tells me how much I need. So I'm going to go 5, 10, 15. That'll work just fine. You have to have markings on your bars. You can't just put numbers anywhere randomly. You need to clearly tell me where does that number go. And now it's just a matter of plotting it. So 22.5 is right here. And close enough is good enough. Like when it's decimals, I'm not going to split hair over, is it a little bit over to the left or right? If it's approximately where it should go, we're good. 0.15 is here. Right there. And you need to use a ruler for this, okay? No squiggly lines here. And then just cross those 2 points, extend. It's nothing wrong with extending right now because it's not a word problem. And the province calls for a title or the equation of the graph. And I much rather use the equation, and then you're done. Okay? Was there a min or a max here? No. Okay? If it doesn't turn, there's no min or max in this case. All right. I'm going to stop here because I know it's been a lot. I want you to try at least 2 graphs, okay? Let me just be a bit selective here. Pages 9 and 10. So homework. Listen carefully. I'm just asking you to do 2 graphing questions, right? That is, I think, very doable if you sit down and try that. I know that some of this might be has been a while since you last done this kind of stuff. I know that, and maybe you've never done this. So part of the process is to maybe try to relearn. Step number 1 is see what you know without even graphing it. Step 2 is type this into your calculator and find a window that works. Okay? Mr. Dixon, how do you know a window is good? If I see all of the intercepts and all of the max and min if it applies. That is a good window. And then you just go ahead and graph it. Okay? I'll post a key to more than just those 2 if you want to do more. And by the way, most of the graphing scenarios on the exam are word problem related. So I'm not going to spend a whole lot of time doing these ones that don't have a word problem, but it's really good practice to figure out your window. Those of you that are new to this program to apply, you may use Zoom. Zoom Standard always resets your window. So let's say you just worked on a problem and it's just very weird for the next question. Zoom Standard resets it. You may also use, if you keep going further down, there's something called Zoom Fit. Sometimes that does a pretty good job at fitting in everything you need to see. And other times it does a terrible job. It kind of gets you there, but you still need to make more adjustments. So you got to go between window and Zoom to figure out what works. And every time you make a change to your window, quickly graph it so you see the effects of the new values. Otherwise, you won't know what you're doing, okay? Thank you, guys. Hopefully today wasn't too bad.